In this video, we'll decide if the series starting at n equal to 2 and going to infinity of the terms n over the natural log of n squared, notice that's the entire quantity that's being squared, whether or not this series converges. I started at n equal to 2 because the logarithm is 0 at 1, so it would be dividing by 0, and I'm just avoiding that possibility. One of the first things you should consider when looking at a series and deciding whether or not it's converging is whether or not the nth term test applies to the series that you're looking at. One way of interpreting what the nth term test says is that if the series is to converge, then the terms of my series, the individual numbers that I'm adding together, must approach 0. So let's check it in this case. I need to look at the limit as n approaches infinity, and I'm going to look at it for the terms of my series that I'm looking at, n over the square of the log of n. And I'm going to think about what happens as n gets large here. The numerator is going to go to infinity, and if I look at the natural log, that will go to infinity as well, and then I'm squaring it, so it even gets a little bit larger by squaring it, and I'm looking at something of the form infinity over infinity. This is an indeterminate form, and L'Hopital's rule applies to this situation. So I can take the limit by instead comparing the derivative of the numerator, the ddn of n, and the derivative of the denominator, the derivative of the log of n squared. So let's carry out L'Hopital's rule now. I'll take the limit. I'll take the derivative of n, that's 1. And then I need to use the power rule on this expression, so it will be 2 times the log of n, and then don't forget to use the chain rule here. The derivative of the log of n will be 1 over n. I now have a new expression which I can reassess. Simplifying here, if I'm dividing by 1 over n, that's the same thing as multiplying the top and bottom by n, and that would give me n over 2 times log of n. So one way of getting that is to multiply the top and bottom of this expression by n. And if I analyze the form as it stands right now, I still see infinity in the top, n is going to infinity, and the logarithm still going to infinity, so I still see another indeterminate form, and I can apply L'Hopital's rule one more time. The derivative of n will be 1, and the derivative of 2 times the log of n will be 2 times 1 over n. Simplifying in a similar manner as before, if I'm dividing by 1 over n, it's the same thing as multiplying by n, and so this expression is really n over 2. As I let n go to infinity, this expression goes to infinity, and so what we've concluded here is that the terms of my series do not in fact go to 0. As a consequence of this, the nth term test tells me that my series must diverge. If it was to converge, those terms should go to 0. Because I didn't get 0 here as an answer, there's no possible way of this series converging. As you add more and more of these terms together, this limit here is telling you that you should get partial sums that increase in size.